Hello. Today's lesson, as you can see, is about rational numbers. What are they, and how can you show that a number is rational? Well, let's get right to it. So, you remember that so far we have learned about the integers. And the integers are all the numbers that are on the lines. They include 0, they include negative numbers, they include positive numbers. What they do not include are the numbers in between. Then we learned about the natural numbers, and the natural numbers were the integers that were positive, but they still did not include any of the numbers in between. So today we are learning about rational numbers, and rational numbers are in between. They are numbers such as They are numbers such as 2.5, 3.5, negative 4.38 with the 38 repeating. These are all rational numbers. However, remember how natural numbers are just a subset of the integers? Well, integers are a subset of the rational numbers. Every integer is a rational number. Every natural number is a rational number. At this point, you might be asking, well, if all the integers are rational numbers, and all the natural numbers are rational numbers, and the rational numbers are the numbers between the integers, what have we left out? Well, it's hard to explain, but there's numbers we left out. I'll get to it later on. Okay, so that's the idea of rational numbers. They are the numbers between, but they're not all the numbers between. There are other numbers between that aren't rational. Talk about that later. So here's the definition. Get this out of the way. Rational number. Any number that can be written as a over b, where a and b are integers, and b is not equal to 0. So since a and b can be integers, that means a and b can also be negative numbers. But they can't have fraction parts. So you can't have a fraction inside a fraction. And b can't be 0 just because you can't have a 0 in the denominator, because for the same reason that you cannot divide by 0. Okay? It's a long way of saying that a number is rational if it can be written as a fraction. So if you have a number and you can write it as a fraction, that number is rational. It doesn't have to be written as a fraction as is. It just has to be able to be converted into a fraction. All right, so what types of numbers are rational? Are fractions rational, like 3/4? Of course they are. They are already a over b. 3 over 4. 3 is an integer, 4 is an integer. A over b. Easy, right? Are natural numbers rational? Well, let's take 24. Can I write 24 as a over b? Of course I can. I can write it as 24 over 1. Or I can write it as 48 over 2. Both of those are equal to 24, and both of those are a over b. 24 is an integer, 1 is an integer. 48 is an integer, 2 is an integer. So far we're doing well. Is 0 rational? Of course. I can write 0 as 0 over 1, or 0 over 5, or 0 over 7,000. All of those are equal to 0. All of those are integer 0 over integer 1, 5, or 7,000. So they are all rational. 0 is a rational number also. Are integers rational? Well, we already did natural numbers, and obviously to me, this should be obvious to you also, but maybe it isn't. Let's say how we can write negative 47 as a over b. Negative 47 over 1. Negative 94 over 2, etc. Those are all equal to negative 47. So they are rational also, because negative 94 is an integer, 2 is an integer. Negative 47 is an integer, 1 is an integer. Are decimals rational, like 4.58? Yes, because this 8 is in the hundredths place. See, that's the tenths place, and that's the hundredths place. You remember decimal place value. And so this, how many hundredths is it? It is 458 hundredths. And look, 458 is an integer, 100 is an integer. That is a rational number, a over b. So I'm left one out. Let me write it in. I have a different idea. Are mixed numbers rational? Well, let's try 6 2/3. And you might say to me, Mr. Zengerle, that's already a fraction. And I'll say, no, it isn't. It's a mixed number. We need it to be a fraction. We need it to be a over b. This is not a over b. This is a, b, c. It's 3 things. We only want it to be 2 things, a over b. Well, here's the trick. 6 times 3 is 18. 18 plus 2 makes 20. 20 over 3. Yeah, all you do is you change it into an improper fraction. By the way, I love improper fractions. They're great. I prefer them to mixed numbers. Mixed numbers are horrible. Anyway, side note over. Let's come back. 20 is an integer. 3 is an integer. It's equal to 6 2/3. 6 2/3 is rational. So, very interesting. Fractions are rational. Natural numbers are rational. Zeros are rational. Integers are rational. Decimals are rational. Mixed numbers are rational. How about repeating decimals, like 0.6 repeating? You remember this is 0.6666666 ... going on forever. Well, let's take 2/3. Let's turn that into a fraction. So I'll do 2 divided by 3. Put a 0. 3 goes into 26 times. That's 18. That's 2. Look, I get another 0. There's 0.6 repeating. So can 0.6 repeating be turned into a over b? Yes, it can, because it equals 2/3. Now, I happen to know that one. There is, in fact, a procedure for turning a repeating decimal into a over b, into a fraction. However, I'm not going to show it to you yet, because you need to know a bit of algebra for it, and I haven't taught you algebra yet. Perhaps later in the year. Okay. So, all of these different types of numbers are rational. Are there any numbers that are not rational? Yes. Those are non-repeating, non-terminating decimals. Non-repeating because they don't do a repeating pattern like 6, 6, 6, 6, 3, 8, 3, 8, 3, 8, 3, 8, 3, 8, things like that. Non-terminating because they never finish. They go on forever. Here are some examples. 0.01, 001, 0001. The next one would be 00001, etc., etc. Notice the way this has a pattern, but it doesn't repeat. Can't be turned into a over b, not rational. The square root of 10. We haven't done anything with square roots yet. Don't expect you to understand it. It never comes out to you can never finish the decimal equivalent of it. Goes forever, never repeats. Not rational. Pi. Pi is a number that deals with circles. You probably have heard of it before. You may have been told it's 3.14. It is not 3.14. It is approximately 3.14. It is actually written as a decimal. Pi goes on forever and never repeats. So, these are examples of numbers that cannot be turned into a over b. Therefore, these are called irrational numbers, and an irrational number is a number that cannot be turned into a over b. We are not going to be dealing too much with irrational numbers yet. I just wanted you to know that they exist. All right. So, prove that these numbers are rational. This is what you are going to have to do on the worksheet today. So 6, well, turn it into 6 over 1, or I could put it as 12 over 2, or I could put it as 18 over 3, or I could put it as 36 over 6, etc. You just need to write it, the number over 1, or some other equivalent fraction. Negative 12, well, negative 12 over 1, or negative 24 over 2, or negative 36 over 3, etc. 3.764. Well, what's the place value of that 4? It's in the thousands place, so I know that the denominator is going to be 1,000, and the numerator are all these digits, but remember, there is no decimal point. The decimal point is there to tell you where the ones place is. We don't care what the ones place is anymore, so we do not put a decimal point. Besides, it has to be a over b, where a and b are integers. This is not an integer. It has a fraction part, so it can't be in the numerator. This has to be an integer, and this has to be an integer. Integer, integer. Therefore, no decimal points. Okay? 8/11. Well, however, what am I going to do to write 8/11 as a over b? It already is a over b. All I have to do is rewrite it. 8 over 11. 8/11. A over b, done. 3 and 2/5. Remember, this is a mixed number. It has 3 things, 1, 2, 3. We want to only have 2 things. We want it to be a over b. Well, you change it into an improper fraction. 3 times 5 is 15, plus 2 is 17, 17/5. And there it is. Those are rational numbers. That is how you show that things are rational. You turn them into a over b. That's the only way to do it. There is no choice. There are no words needed. All you have to do is put equals and then put it in as a over b. That's it. That's the idea. Ask any questions if you have them.